Hello dear students. In this video, we'll start with the infinite series as well as special functions. Particularly in this video, I'll explain you what is the infinite series, how to test the nature of the infinite series by using the Cauchy's root test. First of all, we'll see what is the infinite series. As you will know, some of the terms of the sequence, nothing but series. Okay. A series containing infinite number of terms is an infinite series. Okay. And this summation will be meaningful if there is no significant change in the sum as more and more terms gets added up. That is the concept of convergence. We discussed the aspect of convergence and divergence of an infinite series of positive terms which are attributed as nature or the behavior of an infinite series. We use well-established test so as to draw a valid conclusion on the nature of an infinite series. We focus on two tests. One is the Cauchy's root test and another is D'Alembert ratio test. Okay. If un is a function of n, un is some function of n and it is defined for all integral values of n. An expression of the form u1 plus u2 plus dot dot plus un plus up to infinity containing infinite number of terms is called an infinite series. Usually this series is denoted as sigma n is equal to 1 to infinity un or simply sigma un. Un is called the nth term or the general term of the infinite series. Okay. Now, the sum of the first n terms of the series is denoted as Sn. Sn denotes the sum of the first n terms of the series. That is, Sn is equal to u1 plus u2 plus u3 dot dot up to un. Sn denotes the sum of the first n terms of the series. Now, a series sigma un is said to be convergent if limit of Sn as n tends to infinity is equal to L, where L is a finite quantity. What is Sn means? Sn is the sum of the first n terms of the series. If I take the limit of Sn as n tends to infinity, if it is a finite quantity, then sigma un is said to be the convergent series. And similarly, sigma un is said to be divergent if limit of Sn as n tends to infinity is equal to plus or minus infinity. Okay. Before telling what is the Cauchy's root test, okay, we need to remember this. Geometric series 1 plus r square plus dot 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 plus r power n plus dot 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 is convergent. That series is convergent if r is less than 1 and divergent if r greater than or equal to 1. Also, the harmonic series or power series sigma 1 divided by n to the power of p, okay, is convergent if p is greater than 1 and divergent for p less than or equal to 1. Now, first we will discuss the Cauchy's root test. If sigma un is a series of positive terms and if limit of un to the power of 1 by n as n tends to infinity is equal to L. Okay, un is the nth term of the infinite series. If I take the limit of un to the power of 1 by n as n tends to infinity, if it is comes out as L, okay, a finite quantity, then the series is convergent if L value is less than 1 and the series is divergent if L is greater than 1 and the test fails if L value is equal to 1. In such cases, we need to go for some other test. Okay. But it is not there in our syllabus only. Okay. Whether it is convergent or divergent, we supposed to find. Right now. And when to apply this Cauchy rule test means, okay, that un, nth term, if it is of the form f of n to the power of g of n, then we are applying the Cauchy's root test. And also limit of n to the power of 1 by n as n tends to infinity is equal to 1, and limit of 1 plus 1 by n to the power of n as n tends to infinity is equal to e is approximately equal to 2.7 something, and limit of 1 plus x by n to the power of n as n tends to infinity is equal to e to the power of x. You need to remember these results. Okay. And first of all, you need to remember, okay, we are applying the Cauchy's root test if un is of the form f of n to the power of g of n. Okay. Now I'll show you how to do the pronouns on this. Test for convergence for summation 1 plus 1 by root n to the power of minus n to the power of 3 by 2. Okay. Here nth term is un equal to 1 plus 1 by root n to the power of minus n to the power of 3 by 2. Okay. First we'll take un to the power of 1 by n. Okay. 1 plus 1 by root n to the power of minus n to the power of 3 by 2 whole to the power of 1 by n. That is equal to 1 plus 1 by root 10 to the power of minus n to the power of 3 by 2 into, okay, a power m whole power n is a power m into n. That's why into 1 by n is nothing but n power minus 1. That's equal to 1 plus 1 by root 10 to the power of minus n. Bases are same, we can add the powers. 3 by 2 minus 1 is 1 by 2. That's equal to 1 plus 1 by root 10 to the power of minus n power 1 by 2 is nothing but square root of n. Now consider limit of un to the power of 1 by n as n tends to infinity. That is equal to limit as n tends to infinity 1 plus 1 by root 10 to the power of minus root 10. That is un to the power of 1 by n is 1 plus 1 by root 10 to the power of minus root 10. That is equal to limit as n tends to infinity 1 divided by 1 plus 1 by root 10 to the power of root 10. Okay, it is of the form 1 divided by 1 plus 1 by m to the power of m as m tends to infinity. That is nothing but a standard limit. Its value is equal to e. 1 divided by e. 1 divided by 2.7 something means it is less than 1. Hence, by Cauchy's root test, sigma un is convergent series. One more. Discuss the nature of the series. Sigma n is equal to 1 to infinity n plus 1 to the power of n into x to the power of n divided by n to the power of n plus 1. Here un is n plus 1 to the power of n divided by n to the power of n plus 1 into x to the power of n. Un to the power of 1 by n. N plus 1 power n whole power 1 by n. X power n to the power of 1 by n. N to the power of n plus 1 to the power of 1 by n. N 1 by n gets cancelled in both the terms of the numerator. So it is n plus 1 into x, and in the denominator n to the power of n into 1 by n is 1 plus 1 into 1 by n is 1 by n. We can split the term as n into n to the power of 1 by n. That is equal to limit as n tends to infinity. In the numerator n plus 1, just have taken n outside. Okay, n into 1 plus 1 by n into x divided by n into n to the power of 1 by n. Okay, n gets cancelled. And if I apply the limit as n tends to infinity, 1 plus 1 by infinity is 0 into x divided by limit of n to the power of 1 by n as n tends to infinity is 1. In the note I mentioned it right now. Okay. 1 plus 0 into x is x divided by 1 is x. Okay. Now, by Cauchy's root test, sigma un is convergent if x less than 1 and divergent if x greater than 1, and the test fails if x is equal to 1. I hope you followed it. Right? Similarly, I solved few problems. Try to solve these problems. Okay, learn. If you get any doubts, feel free to ask the doubts. Okay, in the next video I'll explain you what is the D'Alembert ratio test. Okay, till that, take care. Bye.